All right, so we're in Algebra 1. Today's date is Wednesday, December 4th, 2019, 12/4. Today we are on lesson 5-4, System of Equations with Elimination. So today is kind of the intro to Elimination Day, and then tomorrow is the Advanced Elimination Day. So this is just how do we begin setting up the problems. All right, so our objective, who's going to read it? Looks like the first card up was Jade.
Perform the first few steps of elimination to get an equation with one variable.
Boom, there it is, right, thank you. So, here's a puzzle for you guys. I want you to figure out how much x and y weighs. So tell me x weighs 2 or y weighs 5. How much does x and y weigh? This is similar to yesterday because it's the same goal. You can see it's the same exact goal down here, but a different method.
I get it. I figured it out. Wait. Yeah, I did.
So on the side, go ahead and write down x equals y equals on the left-hand side out here underneath puzzle, and I'll come around and see what you guys got. So how many people have an answer again? Let me see those hands. And keep your hand up now if you would be willing to explain it to the class how you found your answer. Ugo.
That doesn't match up at all.
I got x is 3 and y is 2.
How'd you get x equals 3 and y is equal to 2?
Because for x, there's, when you add 2 x's, it's 6. When you add the y is 2, they equal to 8.
Okay.
And on the other side, the x is 3 and the y is 2 and it equals 5.
So it definitely works out, yeah. Did you kind of use guess and check to find that? Did you just guess, I'm going to say y is 2, and then you're like, oh, if y is 2, x is 3, and then you checked it for both of them and it worked out? Kind of like that? Okay, nice. Did someone have a different way of solving this? I'll take your card, Ugo, thank you. Yeah, what?
Okay. So, I first looked at the values on the right side of each scale, and I saw that on the left one it was 8, on the right one it was 5. And then I saw that on the right one x was missing. So I tried to calculate how many pieces were missing on the right side to calculate how many for x, and I got 3. And then if that was right, I put 2 3s in for the x's, so I got 6 on that side. And then I got 2 for y, and I checked it on the other side, and I got x is equal to 3 and y is equal to 2.
Nice. And that process is really, really close, and maybe I'm misunderstanding you, but it might be exactly the method that we're going to be learning today. It's looking at like the blank spots. How can we take things off and look at the blank space to figure out what's going on? Yeah, Charles.
I looked at the left side on what two numbers were there. So first I looked at 4, but that couldn't work because there was a y. And then I put it down to 3, and there was 2 for y, and so I put that on the right side and got it.
Oh, okay. So 4 wouldn't work because that would mean that y would be weightless, right?
Yeah.
Okay. And then you kept going down. Okay, so it's kind of like a systematic way of doing your guess and check then.
Yeah.
Nice. Okay, yeah, I like it. I'll take a card. So I think that we can all agree that these two scales, if I turn them into an equation, 2x and y, so 2x plus y, is balanced with 8. So this first equation represents this first scale, and x plus y is the second one. That we can see the similarity there. So in terms of what's happening with these scales, I think this is really close to how Wyatt said it, and I might be a little bit off. But I can go ahead and take off an x and a y. If I take off an x and a y, if I take off an x and a y, then how much should I take off this right side? If I take off an x and a y on the left side, how much should I be taking off this right side of this scale? Larissa.
2.
Why 2?
Because 2 of the squares will fit in one of the x and y boxes.
Careful. So use this right scale. If I take off an x and a y, x and y balances with what?
2.
X and a y balances with 1, 2, 3, 4, 5.
Oh.
All right. So tell us the procedure again. If I take off an x and a y, what should I be removing from this right-hand side? 5. Because that's balanced. Like if there's a balance of x and y and 5, then if I take off x and y over here, I can take off 5 over here. This is perfectly balanced, so if I take them off, they should still be perfectly balanced. So let's say if I take off x and y, cross them out on your notes. Cross off an x and y, which means we have to cross off 5 and cross off 5. question. Yes, Asha.
Could you figure that out the same way by just doing 3 plus 2, or does that not always work out?
It doesn't always work out, yeah, unfortunately.
I totally get it.
Now that we've crossed off a bunch of stuff, we're like basically done. It's like, oh, all we have is x. All we have is 3. X is therefore 3. And then you can plug it back in and say, well, if x was 3, then you can take off an x, take off 3, and y is equal to 2. It's kind of like balancing and unbalancing these scales. Question? Yeah.
How do you do it in equation form?
Great question. That leads me into the equation. So we're going to do the exact same thing, but now with numbers. What I'm going to do is I'm going to take off an x and a y and a 5 from my first equation. So essentially what that means is I'm subtracting this equation minus this equation.
I get that.
So 2x minus x. Shout it out. 2x minus x. Everyone says
1x.
there it is, x or 1x. Now I'm going to say y minus y is, shout it out,
0.
0. So I can say plus 0 here. And then finally, 8 minus 5, shout out, is 3. And there it is. That's the equivalent way of doing it with algebra. And therefore, x is equal to 3. I mean, that boils down to just x equals 3.
Wait, so that's literally all we're doing?
That's elimination.
Really?
It gets harder. Like, it gets a lot harder. This is the very first baby step that you're taking right now.
So how do we
what do you do if one of them's negative?
Then, yeah, so the negative doesn't really apply to the analogy up here because we can't, like, unless it's helium, right, pulling up instead of weights going down, it doesn't make sense. But you can still do the same thing if you subtract them and get negative x equals 3, just multiply both sides by -1 or divide both sides by -1. It's still going to work with algebra. Yeah, that was a good question. Charles, what was the question?
So how do we figure out y then?
Oh, yeah, so how do we figure out y? Then we, very similar to substitution, now that I have x equals 3, that x is 3 and that x is 3, plug them into either equation. I think this one is a little bit easier, the second one. So say that x is 3, over here on the right-hand side, rewrite this second equation now.
Oh.
This x is 3, and then I add plus y is equal to 5. I'm rewriting the second equation, but I'm substituting this x equals 3 into this second equation. And then I solve again. It's very, very similar to what you just did yesterday. And then I subtract 3 from both sides, so minus 3, and therefore y is equal to 2 because those canceled out. And that's exactly what we just got up here with the puzzle. You can box it, and you can have your final answer with 3, 2 is the solution to that system of equations. I saw Larissa's hands first, and then Charles.
What happens if we would do the 2x, like plug in, substitute 2x plus y equals 3? What if you did that one instead of the one you chose?
Oh yes, let's see what happens, right? I'll do it off here to the side. You guys don't have to write this down unless you want to, but if you want to be good note takers, you can. What happens, I think the question is plugging in this 3 right here, right?
Yeah.
So let's go ahead and do that. So if I say 2 times 3 plus y is equal to 8, what's 2 times 3, Larissa?
6.
So I have 6 plus y is equal to 8. Subtract 6 from both sides. Minus 6, minus 6. Those 6's cancel out. Y is equal to, what's 8 minus 6? 2. Y is equal to 2. Y is equal to 2. It doesn't matter which equation you plug into. You will get the same y. That's what it means to be a solution to a system of equations. It works for both of these equations. That's why it doesn't matter which one I plug it into. It works for both. It is the intersection, the point that's on both lines, on this line and this line.
Interesting.
Yeah, great question. And then question again?
I was gonna do the next one.
Oh, ready for the next one already? Charles, what is our goal in general when we're doing a system of linear equations?
To get an equation with one variable, then solve.
There it is. Every single time, somehow you need to get a strategy. You can either use, graphing doesn't really get you with one variable, but graphing just immediately solves it. We could do substitution to get one variable. We could do elimination to get one variable. Somehow just get one variable and then solve. And that's what we just did up here. We didn't even have to solve it. It was already solved for us. So I'm going to do one entire example, and then I'm going to go back and just make sure that we know the baby steps. Because eventually I'm going to be doing equations like this. Example 6 is one of the hardest types of questions I can ever ask you, because if I add them straight down, I'm going to get negative 8x and negative y. Just by adding them straight down or subtracting them straight down, you don't eliminate any of the variables. You still have 2 variables. We did not hit our goal that Charles said to get 1 variable. So there's some cool strategy to get only 1 variable for these guys. So That's why I'm going to back up. I showed you the whole process. I'll do it one more time to show you how it works. Let's go ahead and somehow eliminate a variable. So we can either subtract or we can add. What are we going to do to eliminate a variable? Who sees it? What are we going to do with these two equations? Are we going to do a plus or a minus for both of these to eliminate one of the variables? I see 2 people see it, 3 people see it, 4 people see it. Who has their card? Esha.
I think you would subtract.
So if I subtract, and you guys don't have to write this down until we verify it. So 3 minus 4 is negative x. Negative 2 minus another 2 is negative 4y. And then 10 minus 4 is 6. So it's close. We didn't eliminate the variable, though. So take another shot at it, Esha.
The other one would be addition.
Okay, so you're going to do this for us, Esha. 3x plus 4x is?
7x.
And then negative 2y plus 2y is? 0. And
14.
there it is. Yeah, so the correct answer here was you add them because these are opposite signs. If they're opposite, you just add them. If they were both negative or both positive, that's when you want to subtract. Yeah, Eamon.
I mean, you can look at it. I mean, how it's being done so far is you take the sign of the lower equation to get rid of the top equation.
Yeah, that's a, yeah. So they kind of cancel each other out because of the signs that are opposite, right? Yeah, that's a good insight. Question, Kira.
You can just decide whether to add or subtract. There's not like
There's no rule. Yeah, just try to, again, you're just trying to achieve this goal. Somehow get rid of one variable so you have one variable left. As long as you get one variable, I don't care what you did. As long as you got that one variable. As long as you're like still following the rules of math, of course. Esha, yeah.
So we don't put so we do put a symbol right there, so you put a plus sign in between the 7 and the 0.
Yeah, I guess whenever there's a 0, you can kind of not even write anything if you want to just skip that step. I just put plus 0 so that everyone can see that that is the placeholder. What happens when you do negative 2y plus 2y. Yeah, sorry, I was not being very formal about that. I apologize. And then, yeah, so I have 7x equals 14. Quiet raised hand. How do we solve that equation? What do we do to both sides? Emma?
We add 0
Well, I guess 0 is already taken care of. You can just scribble that out if you want. Both sides by? Say again? Yeah. And go ahead and tell us what our new equation states.
new equation will be x equals 2.
X equals 2. Cool. That's half of the battle. Thank you, Emma. All right. Another quiet raised hand. What do we do next? I have x is equal to 2. I need my next step. Who has it? Does anyone still have their cards out? No, oh, here, yeah.
Okay. So now you need to plug that in to either equation.
Yeah, which one do you want to
I
do?
plugged it into 3x minus 2y equals 10.
Okay, so tell me my new equation then. That way.
So 3 times 2 minus 2y equals 10.
All right, keep going.
And so 3 times 2 is 6, minus 2y is 10. And then you need to adjust the variable alone, so you should go plus 6 on both sides to get negative 2y. No, just 2y equals 16. I don't know if it's negative.
So check this part again, Kira.
So should you subtract? But it's not negative.
Yeah, so you always undo it. So to get rid of the 6x, we can subtract 6x,
Okay.
exactly. So if I subtract 6x, keep going. You got this?
Subtract 6, so that's 0. Oh, that's 4. So negative 2y equals 4, and then divide by negative 2 on both sides, and your answer is y equals negative 2.
Cool. 2, negative 2. Wyatt, yes.
Well, I already did example 2, so I'm ready to solve.
You solved the entire thing?
Yeah.
Oh my gosh, really? Okay. That is great. I'm going to back up. We don't actually need to solve example 2. For the homework tonight, I'm going to make sure that we know how to do the first few steps. I agree that example 2 is one of those easier ones that we could totally solve, but I want to make sure that we can answer just the first few steps like the homework tonight. But I will give it to Wyatt. So what is the, this one only has one step. It asks for the first steps here, plural, but there's only actually one step. And the steps that it's asking for the rest of these examples, what are the first few steps? What are the first few steps? It's always asking the same question. Tell me operations. Am I multiplying? Am I adding? Am I subtracting? Tell me what operations I'm doing. We'll go with Ulysses, yeah.
Add.
Yeah, so just add them. That's the answer. Add first equation with second equation. Second equation. And if you want to just abbreviate, just say add. You'll know what that means. Yeah, Wyatt?
Can I still tell you the ordered pair?
You may tell me the ordered pair. I'm curious.
I think it's 6, 6.
6, comma 6. I will believe you. I think we're going to actually do this problem, maybe the exact problem tomorrow, but thank you. All we're doing for now is just doing the first few steps. Thanks for doing that. Yes,
So does it really matter if you do add or subtract?
it does, yeah. So if I subtracted the first equation, so I'm always conflicted every year whether or not to teach it this way because I'm teaching the procedure instead of like the general idea. I want you guys to get the general idea. The general idea is to get rid of a variable. So if I subtracted, the equivalent of subtracting is multiplying this whole equation by -1. So -1 times 2x, -1 times the 5y, -1 times 18y. If I'm subtracting, I'm really multiplying this whole second equation by -1, which means it turns into a -2x, a positive 5x, a positive 18. Which means now, I'm not very neat at writing, but now if I add them after multiplying by -1, which I'm really subtracting, if I add 5y, and it should be a y there. Oops. Come back here. 5y and positive 18. Now if I add 5y and 5y, it's 10y, and I didn't eliminate the variable. So subtracting would not work. 5y minus -5y is 10y. So you do have to make sure that you're adding and not subtracting. It is different. And I'm sure a lot of other people have that same question, but I don't know if that still makes sense yet. Asha, a little bit more?
So if the
Okay.
so if the signs are different, then you're gonna add,
Yes.
and then if they're the same, you're gonna subtract.
Yeah, let's write that down. Signs different. That means you add. If the signs are the same, that means subtract. That means if they're both negative, you're still subtracting. Subtract. I cannot. Yeah, I think that's spelled right. All right, now we're going to a harder question. This one isn't so straightforward. We're on to example number 3. Example number 3, the answer is not simply adding or subtracting. And it's very, oh, actually it is.
Yeah.
Darn it, example 4 is the one that's tricky. Okay, example number 3. What are the first few steps for example number 3? Emma? It is, yeah. So just subtract. And by subtracting, which variable are you eliminating, Emma? The x or the y? Yeah, if I subtract 4x minus 4x, boom, the x's are eliminated, which is why we call this process elimination. That's it. Ask me questions now, because we're moving on to something a little bit harder now. All right, then we're moving on to example number 4. Now is when it gets harder. My bad. Okay, so now if I add or subtract, both of those variables are still there. I did not eliminate either of the variables. So before you add or subtract, the final answer is going to be add or subtract down here. But before I do that, you need to multiply one or both of these equations by a number. That means if I multiply this equation by 2, 2, 2, or something like that, or multiply this by 8, 8, 8, some number, if I multiply consistently through the equation, and then add or subtract, then I will eliminate the variable.
Why?
Got it.
Charles, talk to us.
You would multiply the bottom equation by 2, so that your -9y will turn into -18y, and then you would subtract it and get
So you have everything correct. So let me state what you did again. And do you have a different answer or the same answer?
I have different.
There are always 2 to 4 answers for these guys. So let me repeat what Charles said, and then we're going to come back to Wyatt because, like, looking at multiple ways is super important. Charles said we're going to multiply every single term in this bottom equation by 2. That's just the same thing as multiplying both sides by 2. If I do that, my new equation is negative 2 times negative x is negative 2x. 2 times negative 9 is negative 18y. And then 2 times negative 3 is negative 6.
You could also do negative 2.
Also negative 2 and then add, right? Yeah. There's, a ton of ways to do this. So after you multiply everything by 2, what I want you to do in your mind's eye, in your imagination, hide that equation. Only look at the first equation and this blue equation that we just wrote. Hide this equation now. Hiding this equation, look at this negative 18y and negative 18y. We have created the same exact term, which means now are we going to add, Charles already said it, so I'm giving him credit. But can someone else also tell me what I'm going to do? If I have negative 18y and negative 18y, what operation am I doing, Jade? I'm subtracting, yeah. So this is the operation that Charles basically stated to us, and we all need to write at least this one down. Multiply second equation, and I'm going to abbreviate, I'm just going to do EQ for equation, by 2. Then subtract.
Mr. Sindel,
Yes, Emma.
why do you have to multiply by 2, like, out of every other number?
So Charles saw that the only way to get the same term here and here, well, that's not the only way, but
Yeah.
one of the ways is to multiply this equation by 2. If I multiply this equation by 2, this turns into 18, which matches up here. We're trying to match these terms. So by multiplying by 2, we matched the 9y, it turned it into an 18y, and now these both match here and here.
Why did you do it for x?
I think so, yeah. And then question here before we move to y.
Why do they have to match? Like, why couldn't you have just added them?
Yeah, what happens if you just add them, right? So if I add them, I get negative 9x and negative 27y. We haven't eliminated the variable. Notice that up here, all of these previous examples, everything matched at least once, right? 4x and 4h matched, which means we can subtract them. On the previous example, example number 2, positive 5y, negative 5y, they're opposites of each other, but they're the same amount, the same number, 5y and 5y. And then even in the previous example from that, we had a negative 2y and positive 2y. So we're somehow trying to match at least one of those variables. And you're not the only one that had that question, I'm sure. Because elimination is a difficult method, and that's why I'm separating it into 2 lessons. All right. Wyatt, it's your turn. Go for it.
Okay, I think you could also multiply the bottom equation by 8 or negative 8. If you multiply by 8, then you're also going to subtract, because your x would then become negative 8x, and if you subtract negative 8x from negative 8x, it's like adding negative 8x and 8x, it becomes 0, and then you solve for y. And if you multiply by negative 8, then you just add simply, because that negative x will become positive 8x. But it is a little more complicated, I think, because the numbers get a little bigger.
That's a good point to bring up, too, yeah.
Oh,
So,
wait.
making
then
sure
the
that-
right side would also be 0.
That might be a little bit easier than that case. I don't know. So I just want to make sure that everyone understands Wyatt's method before we take questions and continue on. If we multiply by 8, it would match up the x's, and then I would be able to eliminate the x's. Again, they would both be the same sign. Both the same sign means I subtract. If I multiply by negative 8, it would be opposite signs. Opposite signs mean you add. All right, questions now. Esha, yes.
So do you have to multiply by 2 different numbers every time?
No. Choose whatever is easiest. Do it once, eliminate it, and you're done. We just want to show you the different ways of getting there. You can choose either path.
And so negative 2x minus 18y equals negative 6, and the other equation are both correct?
Yeah, so what we did was we hid this equation and turned it into the blue equation, or we could hide both of those equations and have the top equation and the yellow equation, and then eliminate. We're just showing you these 2 equations can be generated to eliminate one of the variables from the first equation and one of these colored equations.
Oh, so those aren't our answers. We have to eliminate them still.
Yeah, we're not doing any elimination for the homework yet because this is still kind of hard to wrap our heads around. Well, I mean, for some of us, we're like, we got this down. But I want to make sure that everyone has the first few steps of elimination, and then tomorrow we're actually going to do all the math. All I want from you guys today, again, looking back at that objective, is complete the first few steps of elimination, which is, okay, multiply the second equation by 2, maybe multiply the first equation by 3, and then subtract. I just need to get that down. That's it. That's all I'm looking for today. All right, let's try it again. Example 5. What are the first few steps? Obviously, they can't just add or subtract because none of these match up. So somehow match up an x or match up a y. What are you doing? What are the first two steps? So I'm pretty sure Charles and Wyatt know this. You guys should go ahead of us. Do example 5, example 6, and you can start on Khan Academy.
Finish
And
do
then
the
we
whole
check each
problem,
other.
or just
No, just do the first few steps,
Oh, okay.
and then go to Khan Academy. I think you
I'm
guys
just
got it.
gonna write down what you have to do.
And if you guys are in the same boat as Charles and Wyatt, but you're not as outspoken, you guys can, by all means, go ahead of us. Do example 5, example 6. Check it while we're doing it as a class, and then you can move on to Khan Academy before us. I don't want to hold anyone back. All right. Asha, yeah.
Well, I have a question. So you can multiply by any number.
Any number. As long as you're trying to match up this one or match up this one. So is there anyone aside from Wyatt and Charles that has an answer to example number 5? What are the first few steps? So I have 2 volunteers so far. 3. Oh yeah, Hazi.
You have to multiply the bottom by 2.
Bottom by 2. So if I multiply 2 and 2, what is my new equation going to become?
2x plus 14y equals 18.
18. And then, so let's write out what Hazi just did, and then I'll get your next step in a sec, Hazi. So the first step was multiply
I don't understand what you're saying.
I got it.
second equation by 2. Okay, that was your first step. We multiplied our second equation by 2, technically on both sides if we're being formal. And then what do we do from there?
Or multiply. We can subtract.
Then subtract, and we're done.
No, it isn't.
So in the homework, we're not gonna have subtract. Like we're not gonna
Sorry,
have
yes.
solve it.
Not yet. Does that make you sad?
It's just kind of like if you don't solve it.
You will definitely be doing lots and lots of solving tomorrow, if that makes you feel any better. Yeah.
Wait, so we don't solve it, but we write down the first step.
First steps. Yep.
That's pretty simple.
This one?
I feel like.
Different numbers in this one?
Yep.
Is 7.5.
I love all of your comments. If this is a more confusing way of doing it, you'll see the notes. I already have the notes printed out for you tomorrow. We're doing almost the same problem, but you're just doing the whole thing now. So they're ready to go. Yes.
Uncle, what?
And this one by like different numbers.
All right, so example number 6. I know about half of you have the answer already. Quiet raise hand. What do I do? Emma. Multiply. What am I multiplying the first equation by?
2.
By 2. And the second equation by?
3.
3. Why?
Because, so you get negative 6 on the bottom, right?
So we get, this one will be as negative 6x and a negative 6x. Yeah, maybe I should write that down again.
And then match that with on the bottom, that's how you multiply by 2.
Yes, so if I write down my work, multiply both sides by 2, then I get negative 6x minus 6y is equal to 12. And you said the bottom equation by 3. Let's multiply the right side by 3, the left side by 3. And I get negative 15x plus 6y is equal to 3 times 18 is negative 54. So let's write down our steps so far. Multiply first equation by 2, multiply second equation by 3, and then what's the final step, Emma? Now that I have a negative 6y and a positive 6y, am I going to add or subtract? I do indeed add. Cool, and there's the answer. And that's not the only answer. There are a bunch of answers. I could have said, I'm going to multiply the top equation by 5 and the bottom equation by 3. And you'll notice that there's kind of a key little way to flip. It's very similar to finding the least common multiple. Yes, Esha.
So, are these things going to be on Khan Academy?
Yes.
How do we answer them?
They're multiple choice. And they'll have
No, they're not.
They're not?
No.
They say what happens when you add.
Yeah.
So the first equation, okay, so the first homework assignment is what happens if I just combine the equations. The second homework assignment is multiple choice. Multiply first equation by 7, second equation by 2. That doesn't make sense. And you go on to the one that actually makes sense. Yes, Ulysses. Sorry, I know why it was first. So it was a personal question?
Yeah.
I'll be there in a sec. Yeah. Why?
I was
All right, I'll go do that now.